So in the last video, I discussed about how do we read an Excel dataset in R, right? How do we read in R and how do we clean the dataset? For example, um, how do we find out what are the type of the data? Are those numerical data or categorical data? And how do we change the type of the dataset from numerical to categorical, categorical to numerical? How do we remove the not available data? How do we handle those not available data? How do we handle the missing data? All those kind of things that we discussed in the last video, okay? So in this video, I'm going to show you how do I group a dataset, or how do I divide a dataset into number of groups based on a certain column or certain category, okay? Or how do I create a new column of a certain category? So that's what we are going to do here. Let us take an example here. So the function we use is a subset, okay? This is the function we'll be using here. Let us consider a built-in data set named tooth growth, okay? I name that as X. So X equals to, let's run that again. This is what you see, okay? So what types of data set is this? What is this? If you want to know what is this, then you can type what is tooth growth here. What? Question mark and then tooth growth, right? So what is tooth growth? If you hit enter here, it will tell you what is the tooth growth. It says how many data sets are there, how many variables are there, and what are those variables means, each of those variables or each of those columns. What types of data is that? Length is the first column, that's what it says. Length is the LEN, is the numeric tooth length, is the numeric data, which measures the length of the tooth. SUP is the another column, which is a factor data. It is not a number data, it is a categorical data. Its meaning is supplement type, vitamin C or orange juice. That's the supplement type. And then next is dose. Next column is the dose. That's the next variable. And this is the numerical data. And dose in milligrams. That's what the dose stands for. Okay. Now, so I want to divide this X dataset or the tooth growth dataset into 3 groups depending on the first column. See, there are some numbers 4.2, 11.5, some numbers are like 16.5, some numbers are 22.5 and so on. So what I want to do is I want to group this data into 3 different data sets. How? The first data set, I want to select only the numbers less than 15. And on the second one, between 15 and 25. And in the third one, I want to pick only greater than 25. Let's do. I name the small. Small equals to subset X comma length is less than 15. What does that mean? That means we are picking a subset of X comma where LEN is the first column is less than 15. That's what I did. Okay. Now let us run this. Look at this. All this first column here on the small group is less than 15. It is picking only those values, but while it picks those values of LEN column of this variable, it will pick the corresponding column of SUPP and DOSC. Okay. For example, look at this. First column has 4.2 VC and 0.5, right? 4.2 VC and 0.5. This one is also less than 15, 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 less than. But number 11 is not less than 15. So our small group will miss number 11. Look at that. 9, 10, and 11, 12, 13, 14, 15, 16. All of them are missing. Now only after that is, so whichever value is less than 15 are captured here. So how many are there? How many data sets are there on the first column? What I did, length of medium, length of small, and then $LEN. There are 19. Similarly, the second one I did LEN greater than or equals to 15. Okay, and LEN less than 25 are named as medium. So if I run this one, then you see that data value, how many are there? There are just 25. Similarly for the high, I did that, I got 16. I divided the X data set into 3 groups named small, and then small, medium, and then high. Okay guys, small, medium, and then high. So you can do anything you want to there. You can group differently. For example, I group based on the length, right? But I can group based on the supplemental type, vitamin C. I can pick only the vitamin C, or only the orange juice, or only 0.5 dose. Look at this. Vita C equals to subset of X with SUPP. That's what the SUPP means. The second variable. Double equals. See, if you want to do equals to, then don't forget it must be double equals to. And if it is a categorical variable, you need the quotation mark. Okay guys, so let us do that. That's what you see. And then these are the values with vitamin C only. These are the data with vitamin C on the second column. Similarly, dose. So if you want to do the dose 1 only, see there are 0.5, 1, and so on. So if you want to do that, then you do just dose 1, it is a name, equals subset of X with dose double equals to. See, if it is a numerical data, you don't need quotation, but for a categorical data, you need a quotation mark. Run that. See, this is what it is picking the data with dose equals to 1 only. Okay, so this is one way of grouping. But there is another nicer way that you can plot. You can do so many things. All right. So tooth growth example. Load the tooth growth data. Select. This is the same data set. Okay. Select the first column and named LEN and name it as length. Create a new variable named growth size with 3 categories: low growth, medium growth, and high growth with values less than 15. We were doing the same thing, but I'll show you another way of doing the same thing, okay? And then we'll write a table and we'll do the bar plot. Let us do that. So X equals tooth growth, we are okay. So length, I'm giving constructing that length equals to data.frame. Data.frame means we are picking from that matrix, from this whole data set, okay? B equals to X, first column of the X. So I rename the first column of the matrix X by B, and then that matrix name, that new matrix name is length. Okay, let us do that, and you will see how that is look like. Look at that. So I'm picking just the first column. The name of the whole matrix is length, and the name of the column is B. B is equals to X. This from that X matrix you are just picking that the first column only, and then now I want to create another variable named growth size. How? Length matrix and then $sign growth size means in the length matrix you are creating a new column named growth size, where if length of B, meaning that if the value of the B inside the length matrix is less than 15, you name is low growth. If that is greater than and less than 15 and less than 25, moderate, and then high. Let us run these files. You can click anywhere and then run it. Look at that. This is what you get. It is creating a new column with growth size, and if that value is less, we name low growth. If it is moderate growth, and so on. Right? Now, what you can do next is we want to create a table. Okay, you want to create a table of that. How do I do that? I'm giving a name like D, or you can do T growth. Okay, table of the growth. Table of the growth, and then table of the growth is table and then length and the growth size. So what I'm going to do is I'm going to plot this column only in a table. How many are low growth, how many are moderate growth, so that, and I'm giving the new name T growth, table of growth. Okay, so you use the function table, and the length is that whole matrix length, and I'm picking just the growth size column. Okay, so let us do that. It gives me how many are high growth, how many are low growth, and so on. Now what I'm going to do is from this table I want to plot bar plot. Okay, let's do that. Look at this bar plot, and you can see that the Y limit is between 0 and 40. That's what Y limit. You can assign any number. X level is growth. See the growth, and then Y level is number. Look at that number, and then space is 0, meaning there is no space between the bars. Color is green, and then main is history. You may be wondering why there is like low growth and then just missing the missing the medium growth. See, if you just make it like bigger window, then you will see that missing name. Okay, guys. All right. So not a problem. When you copy this figure, then you will be able to see it. How do I copy the figure? You can do export and save as PDF, and then just name it, and wherever you want to save, just click that directory and wherever you want to save that picture. Okay, and then name the picture. You can give a file name and then just save it. You can save that picture that way. Okay, guys. All right. So the next thing I want to do is, as I showed you last time, how do I read Excel data in R and then do all these things. That's what next thing I want to do. Okay. So first of all, what it says is, let me remove this everything. Let me remove this everything. Let me remove this everything, and then I will do for you guys. Okay. Let me remove this one too. All right. Okay. So what I'm going to do here is, I'm going to this website, copy this website. Okay, guys, copy this website, and then open your browser, paste it here, and you will see this website. On this website, this is a Vanderbilt Biostatistics department website. Okay, and then they have stored some data there, and they have the description of the data set. See, ABM is one data set. They have a different format of the data set there. And then a cat is another data set, crash is another data set, description. So there are so many data sets there. So what I'm going to do here is download the data set abm.xls. Just click this and download wherever you want to download. Okay, just save it in your desktop. Look at this. In my desktop, you can see that ABM is saved here. abm.xls is saved here. What I'm going to do here is, I want to create a new folder called Biostat, and then put that abm.xls into the Biostat. Look at this. I have already created a folder named Biostat. Okay, and what I want to do, I want to drag it and then put it inside the Biostat. It says that there is already one file named Biostat. I replace that. So see, there is a file Biostat there. abm.xls there. You see the abm.xls? I downloaded and dragged it here. Now, so since R likes the CSV file, then XLS file, what I'm going to do here is, I want to open this file, and you will understand this file later. Okay, but for now, what I'm going to do is, I want to change this XLS file into CSV file. How? What I want to do is go to the file and then do save as, and then do see the ABM inside the Biostat. There is an XLS file already. What I want to do is, I want to do CSV. Just go to here, file format, click the down arrow, and then do CSV. Save it. You see that CSV file is, you can see that CSV file here. Okay, guys. Now that CSV file is basically inside your Biostat folder. Now another thing you need to know is, now how do I get to that file? How can I ask R to read that file? Is, first of all, we need to give R the path. So go to the file. You see that on the very right hand side, you see 3 dots there. Click that 3 dots, and you will see, where was that Biostat folder? It was in desktop, right? Let's go to the desktop. Click desktop here, and go to the Biostat folder. You see that? And then open, because that file is under the Biostat folder. Now it will be seen here. Okay, I'm changing the directory. That's what I was doing here. All right. Now go to the abm.csv. Click that, and then go to import dataset. Import dataset. Did you see that? So what you do next is, you want to copy this. Control C, select and Control C. You can cancel this and go to, let's say, A equals to read.csv, and then parenthesis, quotation mark, just paste it. Control V. Control C is copy. Control V is paste. Okay. If you do that, and then if I write A, and then let me run this file if it did right way or not. Okay, yeah, see? It is showing all those. Why it is copying, why it is printing on like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 column here, and then another 14 column here, and another 14 column here, and then another 1 column here. So since it has like, it sounds like there are more than 40 variables. How do I know that? What is actually, first of all, what is this data ABM means? I want to know that first, right? Let us do that. So here, I want to know what is that ABM data means. Let us click very first here. It is called meningitis dataset. Okay. ABM is acute bacterial meningitis. ABM. And you can read more thing about that dataset here. Okay, guys. But it doesn't say anything about what are the variables. How many variables? What is the dimension? Okay. It doesn't say anything. There are ways to do that in the R, but you can read the last one. Contents. Under the contents, you can see that, oh, there are 581 observations, meaning 581 rows, and then 43 variables. These are the name of the variables and the type of the data. Okay, you can do that way. Or another way of doing this is you can do str and then a. That says string of a, right? If you do that, it will say, look at this. You can do so many things there. So these are the data frame. These are the data type. Year is integer data, month is integer, but age is numerical data. Race is factor data. You see that? Factor means categorical. Sex is also categorical data, and so on. Okay, guys? So now what I want to do is I want to pick a subset. For example, I want to do, let's say, B equals to subset of A, right? Where sex equals to what? You need double equals to, okay? Don't forget that. If you want to write equals to, you need double equals to. And then if it is categorical, sex is male. Let's say male, okay? Because under the sex, there is female and male 2 categories. If you do that, and then type B, and then, run this one. What do you get if you run this one, okay? So you will get, look at that. So it is collecting only the male. Look at this. See, under the sex, this is collecting only the male. You see that? Similarly, you can do anything you want to there. Okay, guys. So, for example, let's say C equals to subset of A, right? Because A is the overall the whole data. So you want to do. Let's say I want to select only the people that have, let's say, month equals to 12, right? You can do that. Month equals to 12. So these are the people. These are the people who got the meningitis on the December only, because these are the month, right? So let us do that. So if you do this one and then do C, then you get, look at this. These are the people, they got the meningitis only the month of 12. Look at this. Month is 12, 12, 12. It is picking that one only. All right. But by the way, I forgot to tell you that sometimes, see, it is missing some of the, this says that it is missing 13 rows. I mean, you can see all of those, okay? But it is reached the maximum. It is showing just 340 rows here only, or certain number of rows. It may not be 340, but certain number of rows only, and it is omitted 13 rows. But you can see any those omitted. You can just do tail of those rows, and it will show you that, okay? Or like head equals to C, and then how many rows you want to see. You can check that way. All right, guys. All right, so you can do that way. Now, what I'm going to show you here is, you see that there are so many NA data. You see that there are so many missing data. There are so many NA data. Now I want to get rid of NA data. How do I do that? Okay. So, what is one way of handling the missing data is removing the missing data, right? So how do I do that? This is the code that I use for removing the NA data, okay? So one way is, if there are big data set, and if you remove the NA data, meaning that it will remove the whole row. If you remove a rows of the NA data, sometimes it will remove only few of them because there are only few of NA, and then you can remove those. But if removing NA rows removes most part of the data, many data set, if you lose many data set, then you want to replace that NA by the column means or column modes. That's what you can do, right? So this one is basically doing D. This one is basically removing the NA data. Let us do that. If you do that, oh, there is nothing left. See, 0 rows. There is nothing left because all these variables have NA data. So if you remove NA data, there is nothing left. So we don't want to do that. What we want to do instead is we want to replace the NA data by the column means if it is numerical data, and by the column mode if it is a categorical data. So what is the code? I had given the code earlier how to replace or how to remove the NA data, right? This is library dplyr. So let's do Control C and let's do Control V here. So I am giving the name as E equals, okay? So what I'm giving here is, and then I will type E. So it will replace all the NA values by column means or column modes, okay? So you need to run from this line. I'm doing library dplyr, and then I ran that E mode definition, and then I ran E. Look at that. So there is nothing NA. So all of those NAs are replaced by the column means or the mode. You see that? There may be some missing data. I mean, if there is a blank, it still may leave the blank. But see, the thing that we are looking here basically are all those, all of those. Oh, it is working from C only. Let me do that has from A. Instead of C, if you do A here, because C was this data set only, okay? Only 12 months, the December data only. But if you do that and then click this one and then do that, you will see some of the missing data. You see that? Let me see if there is any missing data there. It might be. See, look at that. Some of the blank data will be still the blank, right? There was gender was not mentioned there. Still the blank. Okay, guys. So that's what it does. So you can do so many things to clean up the data. So basically what I wanted to show you here is how to create a subgroup from a data, and on that time I also showed you how to download an online data, okay, and then save it in your computer, how to access that in R, and then how to read that in R, and how to clean those data, how to work on those data. Okay, guys, thank you very much.